Welcome back to the deep dive. We're always looking at the big topics shaping our world, especially, how we build it. And if you're involved in sustainable building, you've definitely heard people talking about embodied carbon. But how much do we really grasp its impact? Today, we're not just going to define it. We're really digging into how the big certifications like LEV5 are starting to measure it and, importantly, demanding action on it. It's this hidden environmental cost. Did you know that just the materials, the concrete, the steel, the glass for like one commercial building, that can pump out as much carbon as maybe 1,000 cars running for a whole year? It's huge. That's this embodied carbon we're talking about. And it's fast becoming, well, the next big thing in green buildings. Sometimes it's even bigger than the building's day-to-day energy use for decades. So our mission today, to really get you clued in on this invisible climate impact, the footprint behind the buildings where we live and work. And hey, if you find this stuff interesting, how our world gets built, the environmental side of it all, definitely hit subscribe. You'll hear a lot more about this world and how we can maybe make a difference. Okay, so let's unpack this. For ages, the push for green buildings felt a bit incomplete. We know about operational energy, heating, cooling, lights, all that. That was a bad guy. But we kind of ignored this other factor, the carbon footprint that's literally baked into the materials. That's usually the focus, right? The energy use day to day. But what is this embodied carbon exactly?
That's a really good way to put it. Yeah, historically, it's been all about the, let's say, tailpipe emissions of buildings, the energy to run them. But embodied carbon, that's more like the factory floor emissions. It's the hidden cost built into the materials themselves and how we put them together. So technically, it's the greenhouse gas emissions tied to the whole life cycle of the building's materials and the construction itself. Everything from digging raw materials out of the earth, shipping them, manufacturing them into products, and then the actual building process on site, right up until it's finished. And get this, for a lot of these new super efficient buildings, the embodied carbon can be like 50, even 70% of its total carbon footprint over its whole life. It's this huge upfront carbon investment we make, before anyone even turns on a light switch.
Yeah.
It's the carbon cost of making the building, not just using it.
Right, the carbon story before day one.
Yeah.
So what makes this embodied part so critical now? Why are standards like LEE5 making it a non-negotiable, a prerequisite?
Well, it's become critical because our buildings are just getting so much better operationally. Think better insulation, smarter HVAC, renewables. As those operational emissions go down the running costs of carbon, let's say that initial upfront footprint from materials just becomes a way bigger slice of the pie. We're getting pretty good at cutting the day-to-day carbon, so now the big opportunity, the real leverage point, is in that purchase price, the materials and construction.
Okay, makes sense. And this is where it gets really interesting, applying it. You mentioned this specific ILI V5 requirement, MRp2, quantifying and assessing embodied carbon. Now that P in MRP.
Yeah.
What's the deal with that? Is it just a category, or does it signal something more serious for projects wanting to get LEED certified?
Oh, that P is absolutely crucial. It stands for prerequisite,
Oh.
which means it's mandatory, non-negotiable. You have to do this if you want LED certification. It's not an extra credit thing. It's step one. And the goal, the intent of MRP2 is pretty clear. It's about measuring, quantifying the embodied carbon impact, specifically what's called global warming potential, GWP, for the main parts of the project. So the structure, the enclosure, the skin of the building, and the hardscape, like paved areas. But, and this is key, it's not just about getting a total number. The prerequisite also pushes teams to figure out the top sources of that carbon. What's really neat here is how thorough it is. It wants you to understand where the impact is coming from, the hotspots, so you can actually target them. It's about moving from just knowing to doing something about it, actionable insight.
That sounds like a really clear objective. But I wonder, is there a worry that this detailed number crunching could add a lot of cost or complexity, especially, for smaller projects that are trying to do the right thing?
That's a fair point, and it's definitely something the standard tries to address. Yes, there might be an initial learning curve, an investment in figuring out how to calculate embodied carbon. But the idea is that the long-term payoff building more sustainably, using materials more wisely, often outweighs those upfront efforts. Plus, as we'll probably get into, the tools and methods for doing this, they're getting much better, much more accessible. The aim isn't really to create a huge hurdle, but to make sure this massive chunk of a building's footprint finally gets the focus it needs. It kind of forces innovation, which down the line tends to make things more efficient and even cheaper for the whole industry.
I get it. So it's like a diagnostic tool that also pushes for better design.
Yeah.
Okay, so if a project team has to quantify these impacts, What exactly are we talking about? What parts of the building fall under this? Because, yeah, a building is more than just four walls and a roof.
Exactly. It aims for a pretty holistic view, trying to capture the lion's share of the project's embodied carbon. The scope is quite broad. It definitely covers the main structural bits, beams, columns, the foundations holding everything up. Then there's the outer enclosure. Think of it as the building's skin, exterior walls, windows, the roof assembly, everything keeping the weather out. And then the hardscape. That's your paved areas, parking lots, sidewalks, plazas, stuff like that. Non-green outdoor surfaces. But here's a really important detail. It also includes all ancillary structures.
Ancillary structures, like everything else on the site. That does sound holistic, but does that mean like temporary sheds the builders use, or what fits under the LED project boundary here?
Good question. It mainly focuses on the permanent stuff that's part of the final project, or really adds to the built environment on the site. So yeah, like a separate parking garage, maybe some outbuildings, even little utility structures that are meant to stay. It wouldn't typically count, say, temporary scaffolding or the site office trailers. Those are part of the construction process, not the permanent building itself.
Yeah.
So it's about the lasting physical components.
Gotcha.
They're not just the main event, but all the permanent supporting acts on the site, too. Okay, with that kind of scope, I'm guessing the list of materials they need to track is pretty long as well. Are there specific ones LED V5 says you must count?
You're right, it's a defined list. And it targets, well, the usual suspects, the heavy hitters in construction, things that are used a lot and often have a big carbon footprint. So the list includes asphalt. You see that everywhere, in parking lots and roads, often forgotten about. Then there's concrete, huge one. Foundations, structures, very energy intensive to make cement, masonry, bricks and blocks. Structural steel, the skeleton for many big buildings, also takes a lot of energy to produce. Then you've got insulation, super important for saving energy later, but it has its own embodied carbon story. Aluminum extrusions, used for window frames, curtain walls, structural wooden composites becoming more popular because they can be lower carbon, but you still need to quantify them. Cladding, which is the outer finish or skin of the building. And of course, glass. Lots of glass in modern buildings. It's not just a random list. It's a strategic focus on where the major impacts usually are. It really underscores that embodied carbon isn't just one thing. It's spread across many different materials, each with its own story.
Wow, okay. That list covers a lot of ground. It definitely sounds complicated. So once you know what materials to track, how do you actually measure the emissions? It can't just be like putting it all on a scale. Right?
No, definitely not just weight. The main method specified is looking at the cradle-to-gate emissions. That's often referred to by the life cycle stages A1 through A3. So cradle-to-gate, think of it like this. It's everything from pulling the raw materials out of the ground, transporting them, processing them, manufacturing them into the final product, right up until that product is finished and sitting at the factory gate, ready to be shipped to the building site. It captures all the greenhouse gas emissions generated up to that point. It's measured using the material's global warming potential, or GWP, per unit, like per kilogram or per square meter or whatever makes sense for that material. Then you just multiply that GWP value by the total quantity of the material used in your project. If you think about the big picture, it's about understanding that upfront carbon cost before a single thing happens on the construction site itself.
Right, cradle to gate, that really nails down that upfront impact. But I can just imagine the sheer number of calculations. Are teams supposed to do this all by hand, or are there tools to help? That sounds like a massive spreadsheet exercise.
Yeah, that's a very practical point. And thankfully, no, they're not expected to do it all manually from scratch. While understanding the concept is vital, LED V5 definitely encourages and practically requires using established tools. We're talking about life cycle assessment or LCA software or specialized embodied carbon calculators. These tools have huge databases already built in with all the GWP data for thousands of materials and products. They automate a lot of the calculations and make the reporting much easier. So project teams can spend less time punching numbers and more time actually analyzing the results and figuring out how to make reductions. It leverages the tools the industry has already developed, makes it much more feasible.
Okay, that's good to hear. So tools make the quantification manageable. But after all that work calculating the cradle-to-gate GWP for all those materials, is that it? Do you just report the final number? Or does LED push teams to, I don't know, use that information somehow? Maybe tackle the worst offenders?
That's exactly where it goes next. And this is really where the requirement shifts from just measuring to actually driving change. It asks that crucial question, okay, you have the numbers, now what? So no, it's not enough just to quantify. Once you have the results, the requirement is that projects must identify the top 3 sources of embodied carbon within their scope. These are your hotspots.
the materials or the building assemblies that are contributing the most to that total GWP number you calculated. It might be, for instance, the concrete in the foundation is number one, maybe the steel frame is number two, and perhaps a certain type of foam insulation is number three. It varies project by project. The idea is to pinpoint where the biggest impacts are concentrated, so you know where to focus your reduction efforts for the biggest bang for your buck, so to speak. I mean, think about something like concrete. It's often said that if concrete production were a country, it'd be the third largest CO2 emitters in the world. So finding these hotspots, it's about tackling potentially massive impacts.
Right, find the big levers. So they identify the top 3. Then what? Do they just list them out like, yep, concrete was bad? Or is there an action tied to that identification?
Precisely. Identifying them is just step one of the action phase. The really crucial part of the requirement is that the project team then has to describe how they considered and implemented project-specific strategies to reduce the impacts of those top 3 hotspots.
Ah. Oh.
So it's not just awareness, it's accountability. They have to show their work, essentially. For example, if concrete was a hotspot, did they look at optimizing the mix? Using less cement, maybe incorporating things like fly ash or slag, which are industrial byproducts that can replace some cement? Or did they even explore fundamentally different ways to build that part, maybe using mass timber instead of concrete for some elements? The team needs to demonstrate that they didn't just find the problems, but they actively tried to find and apply solutions tailored to their specific project to lessen those impacts. It really pushes for real-world change and innovation.
So let's bring this back. What does all this mean for you, our listener? This look into LED V5's MRp2 shows that the whole idea of green building is getting way more sophisticated, much more complete. It's pushing for real accountability, real innovation, not just about how buildings run, but how they're made in the first place. This whole approach, measuring everything from cradle to gate, finding those carbon hot spots, and then actively trying to reduce them, it really changes the game for the environmental performance of the places we live and work. It makes our built world potentially much, much more sustainable.
Wow, we covered a lot there. We really dug into this critical kind of hidden side of our buildings. We talked about what embodied carbon actually is, those greenhouse gas emissions from materials and construction, that big upfront carbon hit. We saw how LEV5 with this MRp2 prerequisite is making projects measure it from raw materials right up to the factory gate, covering structure, skin, pavement, even extra buildings on site. And maybe most importantly, we learned about that next step, finding the biggest carbon culprits, the hot spots, and then actively working to lessen their impact.
It's way more than just energy bills. It's about the actual stuff our buildings are made of and their whole environmental story.
Yeah, and maybe this leaves you, the listener, with an interesting question to ponder. When you look at buildings going up around you, or even just think about the materials in your own space, what do you guess contributes the most to that embodied carbon? Concrete, steel, insulation, glass. And what cool, innovative alternatives might be out there that maybe we're not using enough yet. It's a huge area, constantly evolving, and just being aware is the first step to maybe pushing for better choices down the road.
Absolutely. What this framework really signals is a move towards truly sustainable construction, looking at the entire life cycle, not just when the lights are on. If you want to keep exploring these hidden impacts and the smart solutions shaping our future, make sure you subscribe so you don't miss out on hearing more about this world. We'll be back soon with another deep dive.